Good afternoon. Welcome to PRL colloquium. Today's colloquium speaker is Dr. Mohapatra, Director General of Meteorology from Indian Meteorological Department. I take this opportunity to thank you, sir, for kindly agreeing to talk to us and address the PRL gathering. In fact, the word weather is something that each and every one of us is concerned, is affected by, and we are all curious to know what is the weather today, tomorrow, day after, or a month later, or even few months later, for various applications, various societal functions, or financial aspects, and so on. And whether we know or not, we use this word weather so often. But today we have a speaker who is expert in these aspects. And to formally introduce the speaker, I have my colleague, Professor S. Ramachandran here. I would request him to introduce the speaker and conduct the proceedings. Professor Ramachandran.
Dear friends, good afternoon. It gives me a great pleasure to introduce and welcome Dr. Mohapatra, today's colloquium speaker, who is the Director General of Meteorology in the India Meteorological Department. Dr. Mohapatra holds a PhD in physics and he has 27 years of experience in meteorology. He has contributed at national and international levels towards the science of weather forecasting and cyclone through research and development, improving the prediction and warning services through application of developed scientific methods and technology, and thereby serving the society by enabling the disaster managers and the general public to minimize the loss of lives and properties. He has brought laurels to the country from various international agencies like UN, WMO, the World Meteorological Organization for effective cyclone warning, and he has been associated with the name of cyclone in the last decade. He has been associated with warning and preventing the deaths of several people, starting from Phylline in 2013 to the latest Nisarg in 2020. So he is aptly named as a cyclone man of India, and it's not without reason he is named as Mrityunjay, the person who can conquer the death. In this case, it is he who is, by his cyclone warning and the development and prediction tools, he is able to save the lives of the other people. He has authored more than 85 research papers in peer-reviewed national and international journals. He has edited 3 books, and for all his contributions, he has received a number of awards and recognitions, including the Doctor of Science from Fakir Mohan University, Odisha, and the Kalinga Institute of Industrial Technology, Odisha. He is also a chairman of many national and international committees, including the task team for finalization of meteorological payloads for the INSAT-4 series of satellites, and a revision of the National Disaster Management Authority guidelines for cyclone management and National Cyclone Risk Mitigation Project under this auspices. With these few words, I invite Dr. Mohapatra to deliver the colloquium on weather forecasting in India, current status and future plan. Dr. Mohapatra.
So good evening, namaskar. I hope the screen is visible.
Yes.
Hello, sir. Okay. So, dear Palam Saf and Ram Saf and distinguished participants, at the outset, I thank VRL and all of you for giving an opportunity to speak on this occasion and to have an interaction with all of you. So this presentation will be basically dealing with the weather forecasting in India, what is the current status, and the future plans. So if you just look at the various types of atmospheric phenomena which are associated with weather or climate, it ranges from a very small scale weather system like a dust devil or a formation of a small scale cloud like cumulus cloud. And it can range even up to the phenomena like global warming or climate change, which occurs over the decades and centuries. So accordingly, the concept of monitoring and forecasting is taken care by the people dealing with these phenomena. And you will find that there will be various types of informations being provided by the weather and climate information institutes or service providers. For a very short range information, it is called as nowcasting. We provide information what is going to happen during a few hours. Then also people try to provide the forecast, what is going to happen during next 1 day, 2 days, 3 days, etc. Then further people also try to say what will be the weather during next few weeks, or in a season, or in a year, or in a decade. This is the temporal scale of the various phenomena as you go away from dust devil towards the global warming. At the same time, also, if you look at the spatial dimension of these weather events, you will find that that also changes. So when you say dust devil, its size is quite less, and you go towards the global warming, it really affects the entire globe. So therefore, this weather and climate information across the globe, you will find we have the various spatial scales to the various temporal scales. As a layman, when we say the weather is nothing but something occurring in the atmosphere at a particular time and at a particular place. So therefore, when you move from one place to other place, the weather changes. When you move from morning to evening, the weather also changes. The weather is instantaneous. The weather change is rapid in nature. And generally, we express weather by the parameters like the temperature, or humidity, or rainfall, or you can say the feeling of, say, how humid it is, or how arid it is, whether it is rainy or not raining, whether it is hot or whether it is cold. On the other hand, when you take the observations of weather at a particular place over a long period of time, then you will be able to find out the averaging of that weather conditions. And that average condition of weather is called as the climate. The climate is also expressed in the same phenomena or same parameters like, say, temperature, pressure, humidity, wind speed, wind directions, rainfall, or any other severity like thunderstorms, etc. But as compared to weather, the climate does not change rapidly. The climate change is a slow process. The climate does not change from place to place also rapidly. You will find a very slow change in the information of the climate if you move from, say, for example, Delhi airport to the central part of Delhi. But the weather, when you go from Palam to Safdarjung, you will find a drastic change. There can be a difference of temperature about 2 to 3 degrees Celsius sometimes in a particular time of the day. So this is basically the difference. While weather is instantaneous and changes rapidly, climate is a slow moving process. Now, if you just look at the history of this weather monitoring and forecasting, you will find that there are many literatures. For example, in ancient literature, you will find that around 650 BC, the Babylonians tried to predict the short-term weather changes based on the appearance of the clouds and optical phenomena such as halos. By 300 BC, Chinese astronomers had developed a calendar dividing a year into 24 festivals, each associated with a different type of weather. Just like ours, we have also the festival-oriented, the weather-oriented festivals. In around 340 BC, the Greek philosopher Aristotle wrote a book called as Meteorologica. So Meteorologica basically includes theories about formation of rain, clouds, hailstorm, winds, thunder, lightning, and hurricanes. Now, coming to the modern age, you will find that the science of weather forecasting started with the electric telegraph in existence in 1835. So by that time, whatever observation you are taking, that is communicated from one place to the other place. The two men credited with this birth of forecasting, you can say Buffett and Robert Fitzroy. Buffett developed a wind force scale, which is also nowadays used in the absence of any measuring technique. Buffett scale is utilized to estimate the wind force. What he did actually, he compared the various types of damages due to the wind force, and accordingly he classified all the types of damages into 12 categories, and it was estimated with the wind speeds. Similarly, Fitzroy's warning service for shipping community started in 1861, so with the age of these telegraph communications. In the world, the first daily weather forecasts were published in the Times magazine in 1861. So, based on all these developments, the storm warning signals were generated worldwide, and hoisting of storm warning was the first weather service which was provided across the globe. In India also, the storm warning signal started in 1864 from Kolkata port. Now, coming to the Indian scenario in the weather forecasting, you will find that in Vedas and Upanishads, there is mention of various types of weather in its processes, especially about the processes of cloud formation, rain, and seasonal cycles caused by the movement of Earth around the sun are mentioned in Vedas and Upanishads. Now, coming little advanced period, Baramir's classical work in Brihat Samhita, you can find out, which is written about 500 AD. You will find the clear evidence of a deep knowledge of atmospheric processes. So it was understood that rain comes from the sun. If you just look at the emblem of IMD, you will find that it is written in Sanskrit, Adityat Jayate Vishti. That means sun creates rain, or rain comes from the sun, which we usually understand now, the water cycle. So it has been mentioned there in the early ages. Kautilya's Arthashastra also contains the records of scientific measurements of rainfall and its application to country's revenue and relief work. So Kalidas in his epic Meghdut also has described about the importance of rain and clouds, and there is no movement of the clouds and relationship with the winds have been described in Meghdut. So coming to the modern age in India, you will find that first meteorological observatory was set up in Calcutta in 1785 and in Madras in 1796. Asiatic Society of Bengal was founded in 1784 at Calcutta and in 1804 at Mumbai. Henry Piddington was a rapporteur, meteorological rapporteur. He was stationed in British India period in Calcutta. He published 40 research papers during 1835 to 1855 in the Journal of Asiatic Society on tropical storms. And he is the person who coined the word cyclone. So therefore, the first science of cyclone and its naming, credit goes to British India, Henry Piddington. IMD used the telegrams as and when it started in India. IMD was the first organization to utilize the messaging system like switching computer for supporting global data exchange. So one of the first electronic computers when it was introduced in the country was used in IMD. It is not the case in IMD alone. Worldwide, as and when there has been some development with respect to communication and computing power, it has been tested in weather monitoring and forecasting. India was the first developing country in the world to have its own geostationary satellite INSAT for weather monitoring. Now, with this background, how we come up over the history to the current status, we have now a vast knowledge about various types of weather occurring in the country and surrounding. And based on that, there has been many hazard zonation mechanism, identification of hazards and its characteristics. And at present, we know that India experiences various types of natural hazards, including floods, droughts, earthquakes, cyclones, heat waves, cold waves, landslides, and many more. Thunderstorms, tornadoes, flash floods, etc. So if you just look at all these various types of natural hazards, you will find that most of these natural hazards occurring in India are weather related. And most important weather comes in the season called as the monsoon season. In the monsoon season, we have about 70 to 90% of the total rainfall of the country. And this season extends from June to September. And during the season, we get heavy rainfall leading to floods, and absence of rainfall leads to droughts. Also, this heavy rainfall leads to cloudbursts, landslides, and many more primary, secondary, and tertiary hazards. Prior to monsoon, this is the pre-monsoon season, which is the March to May, when we experience the various types of cyclonic disturbances, cyclones, depressions, also heat waves, thunderstorms, squalls, and hailstorms also. Similarly, the post-monsoon season, we have the cyclone disturbances again. So we have two cyclone seasons, pre-monsoon season and post-monsoon season. Also, we have got northeast monsoon, which affects the southeast peninsula. And for Tamil Nadu, it is one of the most important positive factor for rainfall. So northeast monsoon provides quite a good amount of rainfall for various socioeconomic activities in Tamil Nadu and adjoining areas. So in winter also, we have got various types of hazards like cold waves, fogs, heavy snowfall, frost, and also the western disturbances. So therefore, if you find that around the year, India is confronted with various types of small scale to large scale natural hazards, which are almost 80% related with the weather. Now, if you look at the weather systems which are affecting India, you can just see in this diagram that you have this type of dotted line. This dotted line, black dotted line, that is called as the monsoon trough. During monsoon season, this monsoon trough extends from Ganganagar to Allahabad and Kolkata. And this monsoon trough is the driving force for monsoon. If monsoon trough is active, it is in the good normal position, India gets good rainfall activity. If monsoon trough shifts towards the foothills of the Himalayas, then rainfall activity shifts towards the foothills of the Himalayas, leading to more rainfall in the foothills of the Himalayas, and hence the floods in Bihar, northern part of UP, and also the northeastern states, including Assam, Meghalaya, and others. If it shifts to the south, then central peninsula, northern part of peninsula, and central India gets good rainfall activity, and all the rivers get flooded. Similarly, if you just look at this blue color, that is the region where you get the fog. The Indo-Gangetic plains is very much confronted with the fog, especially today. Also, there was very large-scale fog in this Indo-Gangetic plain. In the winter, we get, and it leads to various types of transport hazards, especially the aviation hazards and railways and surface transport hazards. We also have the monsoon low pressure systems, monsoon depressions, which move along this monsoon trough, causing good rainfall activity over the region. And we have two types of cyclones, one in the post-monsoon season and the pre-monsoon season, and cyclones occur both over the Bay of Bengal and the Arabian Sea, and usually they affect east and west coast of India. I was talking about northeast monsoon. Yes, this is the easterly wave which accentuates northeast monsoon, and you get good rainfall activity over southeast peninsula. So there are, therefore, you'll find that this region is fortunate to get good rainfall activity, unlike many other parts of the world. And at the same time, it is also confronted with many types of severe weather. These are some of the mappings. You can say that on the left-hand side, this is the tropical cyclone, and this is the map showing how the tropical cyclone developed over Bay of Bengal and Arabian Sea. And these tropical cyclones, usually they move northwestwards, but sometimes they can recurve and change their direction and move towards northeast or towards southwest. So therefore, the entire Indian coast and also the West Bengal and also the Bangladesh and Myanmar coast are affected by the cyclones. So just looking at the hazard proneness of the various districts, you will find that entire East Coast districts are more prone compared to the West Coast districts. Along the West Coast, you see Gujarat is more prone than other states. In the East Coast, you'll find there is red color zones like central part of Andhra Pradesh and here northern part of Odisha and part of West Bengal. These are the most prone areas for cyclonic activities. And this is, of course, earthquake. I'm not discussing about earthquake here. And this is the normal rainfall over the country as a whole. You will find that we get high amount of rainfall across the west coast, that is the Western Ghat region, and also we get high amount of rainfall over the northeastern states, that is over the eastern Himalayas. And there is another zone here in the central part, central eastern India, that is starting from Odisha towards Madhya Pradesh. So what I want to say that if you just look at the rainfall pattern of the country, it is associated with two basic features. One is the orographic features. The country is dominated by the orography along the west coast and also in the northeastern states and the Himalayas. And accordingly, the rainfall is more in that region. And the other one is the monsoonal low pressure systems, lows, depressions, cyclones moving along the monsoon trough from North Bay of Bengal towards, say, Gujarat or Rajasthan. As a result, this east central part of the country gets more rainfall activity. And you will find that this next diagram, this is the flood zonation. All these basic river systems, you just look at, we have the major river system, that is Indo-Gangetic river systems. And that is also the most flood-prone area of the country. At the same time, also we have got flood-prone areas along this east coast, the rivers, and also the Narmada and Arjun Tapi, etc., in the west coast. Apart from the Brahmaputra and its tributaries and branches in the northeastern states. And we have got the drought-prone areas also. These are the red color zones are the drought-prone areas. Basically, Southeast Peninsula is the drought-prone area because of the leeward region of the Western Ghats. And also we've got the Kutch and south part of Rajasthan and some parts of Odisha and here Chhattisgarh area also get less amount of rainfall, and variability is quite high due to droughts in many occasions. Now, if you just look at some of the individual cases like a thunderstorm, you'll find that in a thunderstorm, actually, sometimes you can have the wind speed just like a cyclone. The downdraft, this is called as the downdraft, the wind coming from up towards down, and this is called as the updraft here, from down going to the up. So this, once there is a mature thunderstorm, the wind goes down, so downdraft, and that downdraft wind speed can cause the high damage. This is just an example of the radar picture showing thunderstorm lines. How furious it is, you can just imagine if you sometimes visit the northeastern states or northeast India, eastern states. In the eastern states, it is called as the Kal Boisakhi because it is just like Kal. It occurs maximum in the month of April or Baisakh. So it is called as Kal Boisakhi because it causes number of deaths and also loss of properties. And these thunderstorms move from southwest to from northwest to southeast. Therefore, they are also called as nor'wester. This is a satellite picture of one of the intense thunderstorm activity in a particular day, which is also associated with a tornado in Odisha. And this diagram shows you the frequency of thunderstorms. You can just find out how frequent it is in different parts of the country. No part of the country is free from thunderstorm activity. However, intense and most frequent thunderstorms occur over eastern and northeastern India, and also to some extent over the Kerala and Jammu and Kashmir. Similarly, if you just look at the Hellstorm, you will find that hail also occurs in the country, and more hailstorm occurs along the foothills of the Himalayas and northeastern states. Even then, the central part of the country also experiences hailstorm activity. Hailstorm is dangerous towards the standing crops, and also we have got an multiple record. I will tell you, I am a member of the assessment of the mortality due to the various types of natural hazards in the world. We assessed, found that India has got the notorious record with respect to this hailstorm. In Moradabad, sometimes in 1880s, one hailstorm caused death of around 250 people. There was a marriage procession in the Moradabad town, and there was hailstorm, and people died. Also, it led to death of many cattle and livestock. So, similarly, our region also experiences the lightning. One of the important region. Bangladesh also got maximum lightning, and cyclone, of course, 1970 Bhola cyclone, which crossed Bangladesh, has got a notorious record of causing death of more than 300,000 people. Now, difference between thunderstorm and hailstorm is that the hailstorm is also a thunderstorm, but it occurs it causes the precipitation in terms of hail. It happens because the ice particles in this cloud is highly concentrated and leading to the causation of hailstorms. Now, tornado, yes, we do not experience tornado too much, but however, this region, you can see this top right bottom diagram, you can find out the area where we get the tornadoes. The tornado is nothing but a very small scale weather system, which is the size of about a few kilometers. It will affect only 2 to 3 villages, sometimes, or 4 or 5 villages. But it can have the same wind speed or even higher wind speed than a cyclone. And in a tornado, what happens actually, you will be uplifting of the objects and it will throw away somewhere else. And when this tornado occurs, therefore, it causes loss of lives and properties. This is just an example. Tornado cannot be measured because we don't have that type of intense observation systems. And so tornadic radar are also not available here because we do not go for radar because frequency is very less. We have got the other types of radar for determination of the thunderstorms and cyclones, etc. When this tornado occurs over the sea area, it is called as the water spout. Or when it occurs in rivers or in ponds, it is called as water spouts. So you will find that just like elephant trunk, it sucks in the water, and along with the water, fish also are picked up, and those fish are thrown away somewhere else. So you will find that there is a downpour of fish somewhere else. So it happens with the tornado and the water spouts. So, considering all these disastrous weather events which occurs in the country, India Meteorological Department and Minister of Arts and Sciences always try to have a self-reliance in early warning systems. And you'll be happy to know that India is self-reliant with respect to the early warning of severe weather. We do not depend on any other for our early warning. We ourselves originate our early warning and provide our people. Not only that, we also serve the people outside India. That means we also work for the world welfare. So if you just look at the vision and mission of India Meteorological Department, so what we do actually, our mission is to provide the meteorological observations and forecast for optimum operation of weather sensitive activities, and hence to improve the economic and social condition of the society. For doing that, actually what we do basically, we go for observations and monitoring of weather systems, then forecasting weather systems, then we run the numerical models to generate the forecast, and also we issue various types of severe weather warnings and sectoral applications. There is no such sector perhaps in the world today which is not affected by the weather. So therefore nowadays, gradually as the forecast accuracy is increasing, the sectoral application is increasing, and also demand is increasing for the information to various sectors. To carry out all these activities, also we have research and development. We continuously go for enhancing our capability through augmentation of observational network, augmentation of numerical modeling, improvement of forecasting and severe weather warning, and supported by research and development so that each and every sector gets benefited with information on weather and climate. So another important vision is that no weather hazard to go undetected and unpredicted. So that means the warning should be so accurate against the hazards, and it should be provided in such a reasonable lead time that it can trigger response from the disaster managers, and hence public can be saved and property also can be saved. So with these two important visions and missions, we also support in other sectors like for hazard monitoring and assessment, early warning generation and mitigation, technical support for vulnerability analysis and risk assessment. And we also provide technical support in preparedness and planning, technical support in management of natural resources from disasters like agriculture, water resources, energy resources, etc. So as I was telling that there is no such sector perhaps which is not affected, and therefore we are augmenting our sectoral applications. You will find that just I have written something here, but you will find that there are many other sectors also, be it aviation, general public, disaster support, climate, shipping, agriculture, sustainable development, urban, tourism, petroleum, or aviation, defense. Everywhere you will find national highways and railways, everywhere you will find the application of weather information, and IMD is catering to their requirement. So to carry out all this, we have well-defined organizational structure, and apart from the vertical structure, also we have the horizontal layers. So in the horizontal layers, we have got various functional divisions like agricultural meteorology, aviation meteorology, climatology division, hydro-meteorology, instrumentation, information systems. Then the regional centers to cater to the requirement of the globe. A specialized central center for tropical cyclones, for severe weather events, for flash flow guidance, like that. Then positional astronomy. Perhaps many people do not know that we provide the information about the various astronomical informations, like in a particular city, in a particular time, the time of the tide, the high tide, low tide time information is also provided. And also we provide the various types of Indian calendars. So whatever calendars is prepared in regional language in different states, all those are based on the information provided by India Meteorological Department. So now I'll come to the important part of my talk, that is weather forecasting. When I say weather forecasting, this prediction of, it means basically the prediction of land, atmosphere, and oceanic states in different scales to provide weather and climate forecast in different spatial and temporal ranges. So usually we have a seamless forecasting system. That means we cover all the time scales and also all the spatial scales. In the time scale, we provide the nowcasting, short range forecast, medium range forecast, extended range forecast, and seasonal forecast. We provide every season the forecast for temperature, forecast for rainfall, and also for every Thursday you will find the forecast for next 2 weeks up to 1 month. Then in medium range, every day we provide the forecast 4 times, that is valid for next 7 days. And short range, that is 1 to 2 days forecast, that is provided for the mesoscale events like thunderstorms, hellstorms, etc. And nowcasting is provided for 894 stations and 734 districts in the country every 3 hours. And as per spatial range, you'll find that information is provided at location level, block level, district level, meteorological subdivision level, river catchment, states, and homogeneous regions. So to do all these, over the past few years, quality of weather and climate ocean services improved by augmentation of atmospheric observations, development of adequate modeling strategy, conducting cutting-edge research, and investing in human resource development. Now, in this particular slide, I'll just explain you the entire process of the forecasting and early warning. So what we do, I'll tell you, the weather is an initial value problem. That means if you can detect the weather well, then you can predict it well. So worldwide, therefore, people try to have, as far as possible, most authentic observation of the weather. And while you go for observation of weather, weather occurs in 3 dimensions, and therefore you need information from surface, upper air, and also from the space. So in IMD, also we utilize all the tools which are surface-based, then from atmosphere-based, and also from space-based. The space-based, we utilize geostationary satellites and power-wing satellites. In upper air, we utilize the RSRW, that means radio and radio wind instruments, also wind profilers, pilot balloons, then ground-based radars, and aircraft observations. In the surface, we have the automated weather stations, automated rain gauges, also the manned observatories, which are called as synoptic observatories, meteorological buoys from the ships, aviation stations, and the deployed ships by the Ministry of Earth Sciences. We also have a voluntary observing fleet exercise where the ships flying in Bay of Bengal and Arabian Sea also provide us the information voluntarily with some kind of appreciations. So all these observations are communicated to the forecaster to assess the initial status of Earth, ocean, and atmosphere. So with these observations, the forecaster assesses the occurrence of the various types of weather systems, their characteristics, evolution, growth, and impact. At the same time, all these observations are coded, and these coded observations are fed into an array of numerical weather prediction models. We have got various types of numerical weather prediction models, and about 7 models are run daily by Ministry of Earth Sciences, and also have got international collaboration. We have the model output from various models. So we have therefore about 10 numerical weather prediction models whose output is available to the forecaster. Now you may say, oh, why 10 and what is to be done then by the forecaster? Yes, a forecaster is now bombarded with information, the information from the observational network and also information from the models. Now it is the duty of forecaster now to take a decision and to prepare the end forecast. To do that, he has a decision support system. The decision support system is of two types. One is the objective decision support system, where in a computing platform, we can compare, comprehend, analyze various types of observational network, and also we can analyze the various outputs of numerical prediction models. And taking on these, utilizing the experience and expertise of the forecasting, the forecaster decides the forecast for the particular day. But while doing that, just like a medicine specialist differs, doctors differ from each other, here also the meteorologists can differ from each other based on their experience and expertise, because this decision making is not fully objective. We have got an objective decision support system which brings out about 80% of the decision making. But thereafter, 20%, which is contributed to the forecaster based on the assessment of the modeling output by the forecaster utilizing their knowledge and experience. And finally, it is carried out as an end forecast. So to minimize that difference of opinion and uncertainty among the forecasters, in addition to the objective decision making, we go for some kind of subjective consensus through the video conferencing system. Just like if there is a particular surgery, the doctors go for a conferencing system and they exchange their views and finally they decide what is the disease, who is the surgeon, and who will carry out the operations. Similarly, here we go for a subjective decision making after the objective decision making from the decision system through a video conferencing system. We have got 30 forecasting offices across the country. Every day, 10-30 hours IST, we discuss with each other to come out with a final forecast. That is called end forecast. Now, that is not the end of the road. Once you come to the conclusion of the forecast for the day, that forecast is just a digital value. But that forecast has to be converted into public language. That is called as Public Weather Service, PWS. Now, we have a digital public weather service system where this digital information is converted into a plain language bulletins. Say for fishermen, it is a fisherman warning, or for a disaster manager, it is a particular warning for cyclone or for thunderstorm, etc. So those warnings, when it is communicated, nowadays it is an impact-based warning. That means it includes what is the damage expected and what is the action suggested for the disaster managers, press electronic media, general public, and various stakeholders. So therefore, when a bulletin is received by a decision maker, it is an end-to-end system, and he can take a decision about its applications in various sectors, and he can minimize the loss of lives and property. Now, just going little details, this is a state diagram showing you various types of global observing systems. We have got polar orbiting satellites, we have got geostationary satellites, we have got aircrafts, ocean data buoys, and also you have got various surface stations and upper air observations. So basically, you can find out we have surface observations, upper air observations, marine observations, aircraft-based observations, satellite observations, and weather radars. Now, coming to the surface, we have got the basic. We start with the basic instruments like atmospheric pressure. We have got barometer, baroswitch, barograph. Then we have got wind instruments like wind van, anemometer, anemograph, etc. High wind speed recorder also. In temperature, we have got thermometer and thermographs. Humidity, you have got hygrometer and hygrographs. And precipitation, you have got rain gauge, automated or manual. And for sunshine, cloud, etc., you have got various instruments. So similarly, there are also many other instruments. We look at the entire network of India Meteorological Department, how we meet the observation requirement today. You will find that we have got 203 departmental surface observatories plus 247 non-departmental observatories. That means these observatories are maintained by the state governments, but it is installed by IMD. We pay some kind of honorarium and we get the data. These in the state government or in research institutes or various organizations. Similarly, we have got 39, now of course it is 56 upper air observatories, sky radiometer for environmental monitoring, then pilot wind observatories, high wind speed recorders, glaciological observatories, evaporation stations, radiations, hydro-meteorological observatories for rainfall. It is now about 5,000. And ozone stations, the automated weather stations, I'm talking about IVOF, that is International Voluntary Observing Fleet from the ships, and aeronautical observations, hydro-meteorological observations, like this. And we have got now 30 Doppler radars and INSAT 3D, INSAT 3DR, and SCATSAT. This is the network of upper air observations in the country, which is visible now. You can see that the entire country is well covered with the upper air observations. These are the surface network of various types of observatories. Across the country, you will find that we have got a good network, uniformly distributed across the country. Now, this is the satellite-based observations. The India being such a country which is having the Great Himalayas to the north, Bay of Bengal to the east, Arabian Sea to the west, and Indian Ocean to the south. And also we have got the deserts in the west, we have got the Western Ghats, we have got the Eastern Ghats, we have got the Myanmar Hills, Northeast Hill Ranges, and many more. So therefore, India is naturally a data-sparse region. It is very difficult to have the data observing point everywhere across the country because of the varied physiography and difficult terrain. So therefore, satellite comes handy to have across India or across globe observations, especially the observations from the sea areas and the Himalayas. So this space-based observation therefore helps us to monitor the weather hazards. It helps in physical understanding and developing the climatology and hazard mapping also. You'll be happy to know that not only it is used in real time, but also this data is also fed into numerical weather prediction models. More than 70% of data in the numerical weather prediction model is satellite based. So therefore, it is also, its output is utilized to improve the numerical model forecasting and hence the final forecast issued by the service provider. It has improved that about 25 to 30% improvement in enrollment model forecast comes from the data from satellites. So these are some products from the satellites. You can find that we have got also the various types of tools developed to interpret and analyze the satellite products. So these are some of the products. I'm not going to details how these products are derived, but there are various types of products derived by Indian space organizations and IMD in collaborative manner, and these are utilized on day-to-day basis. So this is the Doppler radar network. You will find that Doppler radar to come up with in 1950, the first radar came up in the country in Dum Airport for wind finding radar for aviation purpose. Then in 1970, when there was Bhola cyclone and it was followed by two intense cyclones affecting Odisha and West Bengal and Andhra Pradesh, then at that time we decided that entire coast should be covered by the radar. In 1974, 10 cyclone detection radar were installed along east and west coast, and which has been now replaced by Doppler radar. Now you can see that about 30 Doppler radars are there across the country, and it is most useful in case of cyclone purpose because cyclones are over the sea and radar along the coast can watch up to 500 kilometers. Now, coming to the different types of methods which we are utilizing for weather forecasting, basically worldwide people utilize three methods. One is the synoptic method of forecasting, then the statistical method, and dynamical method of forecasting. When you go for synoptic method, the word synoptic basically means the simultaneous. Actually, the science of meteorology started with the synoptic. Therefore, meteorology at that time was called synoptic meteorology. So the thing is that people could understand at that time, the satellite was not there, people could understand at that time that weather has no boundary. If you want to monitor weather, you have to take observations across the globe simultaneously. That means the word synoptic, simultaneous, synoptic. So then the concept came to synoptic. Because people thought if you can take observations simultaneously at a particular time over the globe, then all these observations can be accumulated at one place, and hence you can have the information about the globe at a particular time, and therefore you can analyze the weather systems. So this concept was well taken up at that time, which is now being solved by satellite. So to take the observations over the globe. So it starts like that. It's just like a camera, you can say, to take the picture over the globe, but so many parameters are observed at a particular time that it is not possible to plot it in a particular map. So these are coded and plotted and analyzed, and a forecaster, they analyzes all these charts and identifies the weather systems. This is also called as therefore synoptic weather systems. And these weather systems are analyzed at that time, and evolution, its growth, characteristics, movement, decay, etc. also assessed. Now, over the years, now, as I told you, India Meteorological Department started preparing this map in 1881. So therefore, now we have got 140 years of charts of weather maps over the Indian region. So therefore, we are able to develop some kind of climatology of the synoptic weather systems. And this climatology of synoptic weather systems is utilized by the forecasters to provide the forecast. So based on the past characteristics during past 24 hours, and based on the climatology of the synoptic weather systems, the knowledge and experience of the forecast is utilized to provide this forecast. So therefore, in this method, there is no objective tool. So this is a subjective tool. So therefore, just like a medicine specialist assessment, the meteorologist assessment, believing in subjective technique of synoptic meteorology, will vary. And therefore, there will be a difference of opinion sometimes about the forecast among the two forecasters. So, so therefore, what we go for, actually, we go for some kind of consensus development through the discussions. Now, statistical method is nothing but it is the past data for the long period, which you can say time series of variables, and these variables are recorded. And based on this past data, you can find out some kind of statistical association or statistical correlation between various types of predictors and predictant, and therefore a mathematical relationship can be developed, and that mathematical relationship can be utilized to extrapolate and to find out the predictant based on the known predictors. One example of this methodology is the long-range forecast of monsoon rainfall, which is provided every year. Nowadays, we have come up with the dynamical models, but we started providing this type of forecast long back, and systematic regression method came in 1988. So, but the problem here is that this relationship between the predictor and the predictant does not remain same in atmosphere. So therefore, the statistical method memory, which is based on the past few years, cannot be utilized in the current year, in the current date or current time. So therefore, the statistical method has got the limitations. It is very good to predict the mean state of atmosphere or mean weather pattern, but when there is an extreme case, like say climate, cyclone or thunderstorms, or any extreme weather, say higher temperature or lower temperature, the statistical methods have the limitations. So therefore, the most important development took place in the world, that is the numerical weather prediction methods, that is based on dynamical modeling system. That means it takes care of the dynamics of the atmosphere, ocean, and earth system. It started in 1904. The Jerkins was the first person who realized that forecasting weather is an initial value problem. That means he defined that if you can define the initial status of the atmosphere, you can predict it. So that means he urged upon improving the observational system, and hence we have the data, and based on the data, we can predict the weather. In 1920, Richardson attempted to have the governing equations of the atmosphere for the pressure tendency. But however, that prediction what he provided, it failed, but that failure itself helped in better improvement of the numerical regression models. In 1950, it was the first operational analytical model for predicting geopotential light at 500 SPA. So you can say that from 1950 onwards, there has been no looking backward. We have moved forward, and also IMD and India has gone forward in the numerical regression modeling systems. So what is the basis then? The basic realization in numerical modeling is that weather at any place at any time is dependent, or rather a function of 7 meteorological variables. And these variables are wind, 3 components: wind, like east-west component, north-south component, and the vertical component of wind, and the pressure, temperature, density, and the humidity. So based on these 7 parameters, you can have the assessment, the type of weather which is occurring at a particular time. So this basic concept was taken up in development of the dynamical model, and 7 mathematical equations were established, and those 7 mathematical equations are solved with the initial condition of the observations taken from various parts of the globe, and we utilize high power computing systems, and hence at present you will find that within 3 hours a global model is run to provide the forecast for across the globe up to the next 10 days. So this modeling system, when you look at it, you will find that this is the input first. Input means the observations taken from the surface, upper air, and the ocean and space. And these observations are pre-processed to convert in digital form, to have the quality control, to assure the quality in the data. Then these data are assimilated in the numerical models, and then we get the output from the model. When you get the model output, again, this is the 7 parameters only. Those 7 parameters are again post-processed to find out the various conditions for various types of weather, for example, for temperature, for thunderstorm, for heat wave, for cold wave, for cyclones, etc. Various types of post-processing. You can say the model output statistics are also carried out, various types of dynamical statistical modeling is carried out, and also dynamical statistical downscaling is carried out to find out the forecast for a given space and given time. And then it is provided to various stakeholders. So at present, if you look at India Meteorological Department, we have got various types of global models. We have got Ensemble prediction systems like GFS and UMEPS, and we have got the global models like GFS and Unified Model. So I will not discuss in detail about these models. I'll just simply tell you the global model means it can provide a forecast for the globe. And it can provide at present forecast for 10 days, but its forecast accuracy is quite good up to 5 days. Therefore, India Meteorological Department provides forecast up to 10 days, up to 5 days, only with 2 days output. In the location specific forecast, we have got a regional model, that is WRF and SOR for cyclone, and we provide forecast in these up to 3 days. The nowcast tools also there to provide the forecast up to 3 hours and 6 hours. So since I told you that we have got the models which have got the efficiency up to 5 days only, the warning is being provided at present up to 5 days only. Worldwide also you will find that warning is being provided up to 5 days only. So this model which we have, it has got a resolution of 12 kilometers. That means it can provide forecast for every 12 kilometers. That's why we are now planning for the block level forecast. At present we are providing block level forecast for 2,200 blocks, and planning for entire 7,000 blocks in a few years. So the location specific forecast with WRF model has got a resolution of about 3 kilometers. Now, I just wanted to highlight here how important is the satellite data in these numerical models. As I was telling you earlier, 70% data goes to these numerical models. So this is the diagram which shows you various types of data which is going to the models. You can find that how important it is, the satellite. Now, similarly, the quality also will check that satellite data, whatever we are utilizing, also has to be quality controlled and quality assured. ISRO and IMD continuously work to improve the quality of the satellite data. These are some of the examples how this qualitative data of the satellite is being utilized to improve the forecast of the numerical models. Now, this is another example of how the models have been utilized for the cyclone forecasting. When you say cyclone forecasting, apart from those synoptic and statistical tools, we basically depend upon the numerical regression models. In this diagram, you will find that there are many numerical models. All these numerical models are run twice a day, and you can see this is called as multi-model. Various model output. The first day, this is the cyclone Fani, which crossed Odisha coast on 3rd May 2019. You will find what was the forecast here. You see, initially forecast was going like this, towards Tamil Nadu coast in the models, but we did not give that. That you to, I will tell you afterwards what we did. So initially, then finally, you just go day by day, you will find that finally it became very consensus and showing that we're moving towards Paradip and Puri. And finally, this is the output of the GFS model run by IMD. You will find that model is improving gradually over the period of time, and it could provide. You can see this is the cyclone moving. It is showing that it will move near Puri, and finally it moved near Puri and moved towards northeast. So if you just look at, you can, if you count the number of models which are being utilized by IMD, it's about 10 numerical models. The problem is that here, this is just like vectors differ, models also differ from each other. Okay, so these difference of models are taken care by the cyclone forecaster, utilizing their experience and expertise, and also the objective decision support system. So at the same time, the observations that are taken with the satellite radar are utilized to make bias correction in the numerical models, and hence final forecast is provided. Also, I've got cyclone-specific models like SWARF. To minimize this type of uncertainty, what we do actually, we give some kind of probabilistic forecast. For providing probabilistic forecast, we go for the ensemble prediction. when I say ensemble, it is a group or a sample of many numerical regression model forecast. Why should we use GPS? Because it has improved worldwide that the forecast from an ensemble prediction system is better than a deterministic individual model. Just like I told you, doctors differ, models differ. So if you are depending upon only one model, you will be in trouble. So therefore, the concept worldwide is that scheme and ensemble prediction systems. So we utilize the ensemble prediction system to provide the probabilistic forecast of all severe weather. This is just an example of the tropical cyclone Hudhud. You can say that this is the ensemble prediction system. This shows that this is the actual track, and this is the different types of colors indicating what is the probability that cyclone will move here. The maximum probability is here, but there is some probability here, probability here. So you can find out the strike probability with help of the ensemble prediction system. Not only one ensemble prediction system, we have got two ensemble prediction systems from GFS and unified model. And worldwide also we get around 3-4 ensemble prediction systems. So we have therefore an ensemble of ensembles that is called as grand global ensemble system for prediction of severe weather. So this is the benefit of the ensemble prediction system. You can see here. See this ensemble prediction system, when you go for it is showing the best track position will be like this. It is not showing anything, but individual track, if you just go there, it is showing individually some model track is showing that it will move towards South Andhra Pradesh. The weather cyclone Hudhud would have gone South Andhra Pradesh. But if you go by this ensemble prediction system, it is showing no, it will go towards North Andhra Pradesh. So therefore, as a forecaster, we utilize all the opportunities from deterministic model and ensemble prediction models to arrive at a consensus. Okay. Similarly, when I go for a cyclone forecast, it is not simply the track and intensity forecast, but it is also the rainfall forecast, tidal wave forecast, or storm surge forecast, and wind forecast. So, in a cyclone, you will find that it occurs in a particular region. Storm surge occurs here, and here you have got the winds, and all these gray area are the heavy rainfall zones. So, this is the diagram which shows the area where you have got maximum storm surges. You find this area gets maximum storm surge, this is also maximum storm surge, maximum storm surge. So the climatological information also helps the forecaster to assess the real situation. So therefore, it is a practice worldwide. Also, IMD archives all the climatological information. More than 100 years of data is available for all types of weather events. And we have also the specific models for prediction of this one. This is just an example of the collaborative exercise by Mr. Sciences within COES and IMD. This is the coastal inundation modeling or cyclone funny. It shows how much storm cells will be developing near the coast, that is tidal wave developing in the coast, how much area will be inundated, what will be the height of inundation with this type of forecast. So this information is provided to general public and disaster managers for necessary action. So as I was telling you, we have got objective decision support system, which is a geospatial application where you can have all the parameters of the observations and the forecast models, and you can compare, comprehend, analyze, and take a decision. This is just an example of the decision making. Now, once that is done, we'll go for public weather service. In the public weather service, we have the 6 regional centers and around 22 meteorological centers. The 6 regional centers, 22 meteorological centers cater to the need of each and every state in the country. So we provide forecast for agriculture, aviation, shipping, transport, different sectors, and we provide forecast in terms of the bulletins starting from nowcast up to the seasonal forecast. Now I'll just go specific to certain services to highlight how IMD is in job. So this is the cyclone warning services. You will be happy to know that India acts as a regional specialized meteorological center to provide the tropical cyclone warning services for the entire region of North Indian Ocean. So all the 13 countries in this region, starting with Thailand, ending with Somalia, all the countries get the benefit of the cyclone warning services from India Meteorological Department, RSMC, New Delhi. It is one of the 6 RSMCs in the country, in the world, and it has got appreciation for its forecast to all the countries. So it also acts as a regional center for providing international civil aviation organization the forecast on tropical cyclones. So you will find that the information which is provided is very specific and it provides as per the requirement of various stakeholders. For example, we provide sea area bulletin for the high sea shipping. We provide coastal weather bulletin for coastal shipping, trawlers, smaller boats. We provide fisherman warning for fishing purpose. Also, we provide the warning for fishery officials, port warning, aviation warning. Like that, you'll find that 13 types of bulletins are issued every 3 hours and in different stages, like pre-cyclone watch, cyclone alert, cyclone warning, post landfall outlook, and de-warning. This is just an example of the cyclone Amphan in May 2020 this year. It was a super cyclone. You will find that how India could provide. It's just an example. You can see in the in this diagram, this is the wind forecast 5 days ahead, and red line is the forecast track, and black line was the actual track of the cyclone. You can just imagine how accurate was the forecast. Because of the forecast accuracy in track, intensity also could be well predicted, and as a result, the loss of lives could be minimized in Odisha and West Bengal. So this is the cone of uncertainty. This area, we say, though our most probable track was Sundarban area, we told that there can be some variation in the area, but it is the most probable track, and accordingly, Sundarban area was given the maximum warning. So to do that, we have a radar here. Radar picture you can see. This is a satellite picture. This is the ensemble forecast. This is the multimodal ensemble tracks, and this is the rainfall forecast. This is the storm surge forecast. So all these informations are equipped with the disaster managers in the form of a bulletin. You will happy to know that over the years also our forecast accuracy is improving, and there is continuous decrease in error, and accuracy is increasing. This is just another example of cyclone Bulbul, which crossed Bangladesh coast. You can also find out here that how accurately we could predict. It is because of mainly the advancement in observational systems, satellites and radars, and automated weather stations and ships and buoys, and also the modeling systems in collaboration with Indian Institute of Tropical Meteorology, National Center for Meteorological Weather Forecasting, and IMD, and many other research institutes in the country. So outcome, if you just look at because of that, you'll find that from 2013 onwards, there is no such cyclone where the death has exceeded 100. We could limit the death to less than 100. Again, I pray God, I don't want, and nobody will want any loss of life. Further, therefore, there is scope to minimize loss of life. But still, it is a big achievement when you compare the loss of lives of 10,000 in 1999 or 140,000 in Myanmar in 2008. So we have come a long way. It is possible because of the synergy in disaster managers and the early warning service providers like IMD. Okay. Now, similarly, coming to the flood forecasting, we will find that there has been a very good synergized SOP between Central Water Commission and India Meteorological Department. We provide heavy rainfall forecast, and Central Water Commission provides the flood forecast. Over 153 river catchments, we provide the heavy rainfall warning, and accordingly, they provide the flood forecasting. We provide the information of rainfall in a quantitative term, like quantitative probabilistic forecast and deterministic forecast. In the recent year, last year, we have introduced the South Asia flash flood guidance. That means we are providing now in the next 12 hours where you can expect the flash floods. Flash flood can occur because of the very intense rainfall, which is popularly called as the cloud burst, etc. Sometimes, for example, in Gujarat, it happened in Dwarka city this year in month of July and June, and we could provide the flash flood guidance. It was managed well accordingly. So for this purpose, also not only the forecast, also we provide the observations. We have got a system where satellite-based rainfall and the rain gauge-based rainfall are merged, and this data set is prepared every day by the Minister of Earth Sciences and is available to the general public and disaster managers. And this is just an example how every day we prepare the rainfall information apart from the forecast, actual rainfall information. About 130 products are generated every day to cater to the requirement of various types of users. So these are some of the model forecasts for flood purpose. Now, if you just look at the accuracy of heavy rainfall warning, you will find that yes, it is also increasing. Now our accuracy stands out at 80%. 24 hours ahead, we can say that heavy rainfall is going to occur with an accuracy level of about 80%. Now, similarly, the thunderstorm, if you just look at nowadays, the death toll is cyclone is decreased, but number of deaths due to lightning or thunderstorm is increasing. So therefore, 2 years back, we came up with an exercise and set up the lightning warning system. At the same time, lightning detection system has also been established by Minister of Power Sciences and Indian Air Force. So we have got lightning detection now and also lightning early warning. Every 3 hours, very few countries, about 4 or 5 countries in the world provide lightning warning, and India is one of them. And we are providing lightning warning or thunderstorm warning for 894 stations in 739 districts. This color-coded warning, that is impact-based warning. It provides red color means it is most dangerous. So you also will find that our accuracy is quite good, and the probability of detection is about 70%. Now, heat wave, another success story. If you just look at number of deaths due to heat wave in 2015 was around 2040, and it has now decreased in 2020. It was only 4 deaths. So it is impossible because of the combined effort by disaster managers and other stakeholders and IMD. And if you look at the forecast accuracy is increased like anything. Now it is about 93% heat wave warning. 24 hours heat wave warning is 93%, and 5 days ahead accuracy is about 60%. Not only that, we also came up with the extended range forecast, seasonal forecast of temperature and heat waves and cold waves. That is helping in planning. Now, with all these, we have also improved our communication system. At present, you will find that IMD is everywhere. It is in website, it is in API, it is in common alert protocol, it is in social media. We have got the Facebook account, Twitter account, Instagram, WhatsApp, blogs. You can find out like any other service agency. We are venturing into all types of social media apart from the conventional media. Now, if you another service with the which is a flagship program of Government of India, that is the Gramin Krishi Mosam Seva, where we plan to provide the meteorological information, weather information at the village level. We are reaching out about 43 million people in the country. The plan is that we should reach out each and every. Again, it is a public-private partnership. We are going to establish the district level agro-meteorological unit across the country. Already we have established about 200 additionally, earlier it was 200, so total 400. We have got those systems now in the districts. Now remaining districts also will be going to have the district agro-meteorological unit. And by that way, we are providing information to each and every farmer. It is helping them to minimize the loss and improve the yield. For climate applications, yes, we have, as I told you, the seasonal forecast and also the extended forecast, and we are targeting mainly 5 sectors. One is the water, energy, human health, disaster risk reduction, and agriculture. So these 5 sectors we are going to enhance, and we are enhancing already the climate applications. Now, this is just one important information everybody knows. I will not repeat here. This is seasonal forecast we issue for monsoon, because monsoon is live for the country. And we provide various stages of monsoon forecast starting from month of April. We go on updating in different months. Now, if you consider the global welfare, yes, we have the international collaboration and support to global community for climate services over the globe. We have got the meteorological observation data exchange. We provide all our data to the regional, all the countries in the globe. So therefore, the neighboring countries also get benefit of the observational systems in India. We also have the global model and regional model output accessible to all the countries, including our neighbors and South Asia. Support through weather forecast, specific weather forecast for severe weather like cyclone, heavy rainfall, winds, thunderstorms, sea waves are provided to the South Asian countries. The climate data and climate modeling and climate forecast is provided to the region as we work as a regional climate center and provide the South Asia guidance. The capacity building also we provide by imparting training to all the member countries in this region of Asia and Pacific. Also, we help in research development, the climate change issues, the statement, the annual climate statement is provided by IMD, and that statement goes to IPCC. And also we go for the polar research. We have got the station in Arctic, we have got the station in Antarctic, and recently we have come up with a station in Himalayas, also the Himans and services. The expert services through chairmanship and expert membership across the globe is provided by IMD and Minister of Power Sciences. We act as regional specialist medical center for various types of purposes to provide weather and climate information. So, so if you just look at the role of IMD is increasing gradually and bringing laurels to the country and playing a dominant role in the region and the globe. And I am happy to inform you that the improvement in forecast has not only helped India, but also it has helped the countries, others in this region. You can see here, these are the cyclones which affected the countries in Bay of Bengal and Arabian Sea. You will find that there also the number of losses of lives and property has been quite less. Though there is one cyclone, that is Cyclone Ronu, it is 135, it is in Bangladesh plus Sri Lanka. It is not only one. So two countries, total loss of life was 135. But still, there are certain gap areas with respect to mesoscale weather because the entire country is still not covered by the radar. So we are going to cover the entire country with the radar network. That is our future plan. It is basically because this region is very data sparse with oceanic and hilly areas there in the country. So therefore, there is still lack of understanding with respect to the mesoscale processes like cloudburst or very small scale thunderstorms, which causes the loss of lives and properties. So that understanding will come out with the existence of the DWR network across the country and also augmentation of observational systems. There is also still scope to improve the quality and utilization of these observations in the numerical model. So there are gaps with respect to technology vis-a-vis the capability in weather forecasting. That means there is scope to further improve the utilization of the technology available in the country. There is a gap in observational modeling system for forecasting with high spatial resolutions. Because expectation is increasing because of the improvement in forecast accuracy, people also expect the forecast to be provided at their doorstep at the village level or the house level. So therefore, we have to meet the demand and provide the supply. What is our forecast accuracy? For example, the mesoscale events like heavy rainfall, thunderstorm still can be improved further. And MoES plans to improve the forecast accuracy by 20 to 40% by 2030. Another point is that we have to move from simple forecast, impact-based forecast, and risk-based planning that already we have started. And this is what I mean by impact-based forecasting. We have to move from simple weather forecasting to the impact-based forecasting. That means instead of telling that what the weather will be tomorrow, I should say you what the weather will do tomorrow to various sectors. So for this purpose, we have to move from weather extremes to weather translation to hazards, then impact estimation, and response scenario has to be assessed also. So therefore, this impact forecasting cannot be done by IMD alone. It is a partnership program. All the state agencies, space and electronic media, various stakeholders, government and non-government agencies have to work together to realize the impact-based forecasting risk-based one. So this is what you mean by impact-based forecast. At present, we are providing different color codes. Red means excellent impact, green means no impact. When we decide impact, we consider the impact in terms of two. One is, what is the likelihood of occurrence of severe weather? And what is the expected impact of that particular severe weather? But finally, we'll go for the risk assessment, considering the hazard, vulnerability, and exposure. So for this purpose, therefore, you need the data on exposure, data on vulnerability, and of course, hazard data is available with IMD and other agencies. So this is the success story of impact forecast, as I told you, in Saurashtra and Kutch region. That is Dwarka city forecast I told you. And we have introduced this person, and this has been appreciated by the general public. Now, this is the final goal of this impact forecast. So we have to go for partnership, we have to go for risk assessment, we have to go for level of impact assessment, likelihood of impact, hazard forecasting. Then finally, you can go for impact forecast and risk-based warning. And of course, once you generate that impact-based forecast, risk-based warning, it has to be disseminated. For that purpose, Common Alert Protocol is the need of the hour, and Government of India is developing Common Alert Protocol with IMD as a partner. Okay. So as a forecaster, we feel that our forecast information is sufficient for general public. No, it may not be so. If we just look at this type of two wedges, this is from west to east and this is from east to west, you find that initially when we provide the weather forecast, it seems that it is sufficient. But as you go towards the different sectors and the individual public, you will find that it is not sufficient. It needs to be with the information on the impact. So weather and impact, as when combined, then only you will have the complete response scenario, and hence the property can be minimized. The objective of this impact-based forecasting is that loss of lives could be minimized. Now, so next target should be to minimize the loss of property. Okay, so these are the various stakeholders who are working together for this integrated impact-based end-to-end early warning system. So while doing that, that is the role of the technology. You have got the data, now a lot of data from geospatial, data from meteorology, data from various other geophysical hazards, also data from socioeconomic. Then somebody has to process it. So that you need high-power computing system, new numerical modeling system, new impact modeling system. At the same time, for visualizing, for infographics, etc., you need some kind of decision making also. So you need some kind of artificial intelligence or some other tools, and you need the big data concept or the cloud system. So therefore, the basic objective is now to go for a dual engine approach, where you will have the numerical modeling and hyper computing system data, and other hand, you will have the artificial intelligence cloud system big data concept. And with this dual engine concept, we can convert the data to value, just like converting petroleum to the power. So way ahead is that India is self-reliant to a large extent with respect to weather and climate services, and it is helping in improving the socio-economic condition of the country. It has helped in improved infrastructure. In terms of forecast accuracy, we have achieved a lot. We are at par with leading centers, but still there is scope to improve further vis-a-vis the technology available in the country. So MoES and IMD are continuously upgrading their plan and strategy for all the above, and I hope in their future will come across again with improved forecast and warning system to minimize further the loss of lives and properties. So thank you very much for your patience hearing and giving me the opportunity to interact with you. Any questions, please?
Thank you, Dr. Mohapatra, for a very exhaustive talk on what the weather forecasting is and the level of forecasting that is required on spatial and the time scales and the kind of development that we at IMD have undergone and how IMD plays a very important role across the entire region and also contributes to the global scenario in terms of inputs to the IPCC, etc. And you also very nicely elaborated the steps that are being taken to improve and to further better either the system and also prevent more loss of lives, including the developments in the artificial intelligence and the technology, etc. So I'm sure with this such an interesting talk, there will be many questions. Let us now, the floor is open for questions.
Yes, as we are waiting for questions, I would also like to thank and for the wonderful talk. I have one question, which is in regard to the cloud bursts, that happen, and what are the parameters that are required to predict them, and how in much in advance can we predict cloud bursts?
The cloud burst is a very small scale phenomenon. It occurs about over a few villages or sometimes one village only. That means spatial scale is very small. Also temporal scale is very less. It occurs for about half an hour or 1 hour, and it is a heavy downpour. By definition, cloudburst is nothing but a heavy downpour of precipitation, where rate of precipitation is 10 centimeters per hour. That means there is a heavy accumulation of water in a particular place, therefore it causes the floods. So to determine that type of system, at first you need that type of observational systems with that type of spatial scaling. And usually the cloudburst occurs in the hilly regions, which is basically data sparse. So therefore, at present, it is very difficult to detect the cloudburst. So what we are doing actually, we are going for establishing the expand radars. Already 2 expand radars we are inaugurated on the IMD Foundation Day on 15 January. and another earlier it was there in Sonamarg. So now 3 expert radars are there in Northwest Himalayas, and 1 seabed radar is also there in Srinagar. We are going to establish another 7 radars in this Northwest Himalayas. With these expand radars, we will have every 10-minute observations. And I hope that can provide us information about the rate of rainfall or precipitation over the area, and hence it will help to provide the guidance about the cloudburst. Cloudbursts cannot be detected 3 days or 4 days in advance. Only in nowcasting scale, cloudbursts can be provided.
Thank you.
There is a question on which areas, according to you, we need to improve to forecast monsoon more accurately. And is there some inherent limitation that makes the tropical weather systems more difficult to forecast?
Yes, you are correct. Tropical weather systems are relatively more difficult to forecast as compared to extratropics, mainly because the tropical weather systems are associated with the convective systems. So that means you have got a lot of interaction between the ocean and atmosphere. Whereas in extratropics, you will find that systems are very orderly, very systematic, and the convective systems are less, non-convective systems are more. So there is a challenge because of the presence of the mesoscale convective systems. At the same time, the tropical region will find that more or less this is the ocean based. Most of the tropical part is ocean. So this is the additional burden because of the lack of observations from the ocean. So mesoscale convection again occurs in a very small area. So you need that dense network. But however, the satellite is helping in this regard. Also radars along the coast are helping in this regard to detect, and these data are being assimilated in the models. And gradually, if you just look at the forecast accuracy over the tropical region is improving, and I am hopeful in future also it will improve further. And regarding this monsoon, I'll tell you, monsoon is a large-scale phenomenon. It's a global-scale phenomenon, but it is very important over the Asia, Southeast Asia, and South Asia. In monsoon, we try to provide forecast starting from nowcast a few hours up to the seasonal scale. The seasonal, perhaps we are talking about seasonal forecast. The seasonal forecast is being provided initially with the statistical models. The Minister of Science has come up with a dynamical model that is called Monsoon Mission Climate Forecast System. It has been implemented since 2012 experimentally, and we are utilizing now both statistical model plus dynamical model to provide the forecast. But still, we just held 2 days before we had a brainstorming session on monsoon, and we find that there is still scope to improve. So we are going for certain approaches to improve seasonal forecast like multimodal ensembling. Also, we are going for every month forecast like June rainfall forecast, July rainfall forecast, August rainfall forecast, September rainfall forecast, and some of the new tools are going to be developed for that. Similarly, in the extended range forecast is being provided for the meteorological subdivisions now. But the need of the people is that the forecast is provided for districts or cluster of districts already pervasive, but is also on for their purpose. In the short to medium range forecast, yes, we are providing the forecast, and as I told you, accuracy is about 80% for heavy rainfall, but still there is scope for 20% improvement. So gradually this forecast accuracy is increasing, and to do that, we have to improve our data assimilation system. We have to improve the quality of the satellite data, and we have to improve our ground-based observational system so that more and more data, qualitative data are collected, because it is an initial value problem. At the same time, physics for the system has to be well understood. It is being understood. We are also going to have some kind of a research test bed for monsoon purpose in Madhya Pradesh state, in the central part of the country and very close to monsoon trough zone. That will help to understand the physical processes and to parameterize the physical processes in the numerical models. And nowcast purpose, similarly, we are also going to have a rapid refresh system where nowadays, if you just look at the numerical model and the nowcast purpose is being run in a cold start. That means continuous data from radar is not being assimilated there. Now, in the next within this year, we are planning to have a continuous assimilation of radar data in the high resolution model, which will help in improving the nowcast further.
Thank you, Dr. Mohapatra. There is a question on, is there a possibility of detecting and forecasting the fall of mega cryometeors, which are much bigger than ice blocks, which are much bigger ice blocks than hailstones?
we are not dealing with that actually. So we have not tried for that.
Okay. There is another question. What do you think is the role of continentally recycled vapor in Indian precipitation? Are there any existing ways to estimate its contribution?
There are many satellite-based techniques to have the observation of the water vapor in the atmosphere, columnar water vapor, and water budgeting also. And we have the system. We also get the data from the satellite-based system and also from our ground-based GNSS network. At the same time, when you say the budgeting, that means water cycle, etc., there are certain studies. And yes, in the view of the climate change scenario, there are certain changes in the water cycle in certain areas also. Yes, it needs study, and some work is in progress in this process.
Thank you, Dr. Mohapatra. If there are no further questions, I thank you very much on behalf of PR. Now I hand over it to Professor Pallam Raju.
Yeah. Thank you very much, Professor Ramachandran, for conducting this so nicely, and thank you, Dr. Mohapatra, for such a very nice, very nice talk covering various aspects. In fact, our talks colloquium reaches several people who are, ex-PRL faculty and scientists. So I just got a call from one of our senior colleagues, Dr. S.P. Gupta, and he is asking he asked me to ask you to whether what is the relation between global warming and monsoons.
Yeah. Global warming, if you just look at it says that temperature is increased and it is also expected to increase further, and there are various scenarios. And so therefore there are two aspects. One is the past, what has happened actually, and what is going to happen. Now, if you look at what has happened with respect to monsoon, and I would say that all India monsoon rainfall does not show any change. There is no significant change in all India monsoon rainfall for the season as a whole. It is about 88 centimeters. It does not show any significant change. But when you go to the specific areas in the country, there are certain areas where rainfall is decreasing and certain areas where rainfall is increasing. For example, West Rajasthan rainfall is gradually increasing. Eastern parts of the country, Jharkhand, and other areas, it shows a decrease in rainfall activity slightly. This is the quantum of rainfall in the season as a whole. Now, if you consider the daily rainfall, when it is raining, for example, today, on day-to-day basis during monsoon season, it is found that the extremely heavy rainfall events, that is rainfall exceeding 15 centimeters or more in a particular day, those events are increasing. So it is not simply in India, but also in the entire tropical belt of the globe. The frequency of extremely heavy rainfall activity is increasing, whereas the frequency of light and moderate rainfall is decreasing. So as a result, what will happen that if it is not raining, that means it is not raining at all. If it is raining heavily. So therefore, especially in the urban areas where it is raining heavily means there will be water accumulation, and hence it will lead to urban flooding. Or if there is a specific area, there is no scope for water drainage, it will lead to flooding and other issues. This is number one. The number two is that if we have got heavy downpour, then water will move away. The percolation will decrease. And hence, the groundwater reserves also will decrease. It is another part of this one. But it is well understood. We have done study in Ministry of Earth Sciences. Many scientists have done it. It is established that because of the global warming, the water vapor which is being ejected to the atmosphere, the holding capacity of the atmosphere is increased. As the water holding capacity is increased in the atmosphere, and hence when it rains, usually it rains in acidic systems like monsoon low depressions, it rains heavily. So therefore, the region where these low pressure systems are moving, starting from Odisha towards Gujarat, that area becomes more prone for floodings. So otherwise, these are the very significant impacts of the hazards and disasters because of the global warming.
Thank you very much. It's been a pleasure.
If I talk about the forecast, yes, As the temperature is expected to increase, the forecast is that the rainfall may increase. But that is the forecast again. Depending on different types of scenario of the projection of the rise in temperature, there will be different type of.
So it's been, yeah, I'm sure this is a lot of information is there in your talk, and I'm sure once the information is available will be available on the YouTube your talk. So I encourage all the audience and students and researchers to get to view this and get more information. And on behalf of PRL, once again, thank you, Dr. Mohapatra, for speaking to us and for this excellent overview on various aspects. All at one place you have put in, and I really appreciate your taking time to this. And I also thank the colleagues of IMD and other units joining us on this colloquium of PRL. We have this every Wednesday, so I would encourage you to and invite you to participate in various talks of diverse in nature. And that, towards the end of this colloquium, it brings us to the, announcement of the next colloquium also, which is given by Praveen Nahar, Director of NID, National Institute of Design in Ahmedabad. So as you can see, we are covering various diverse topics, not just pure sciences or application sciences, but also how we can change our way of looking at and bringing in innovations. So the title of next colloquium is Design, Thinking, and Innovation. So, and I'm sure that all of us will get benefited in various talks, just as we got benefited in this today's talk. Again, thank you all for joining. Thank you, Dr. Mohapatra, once again. And yeah, bye-bye. See you next Wednesday.